Okay, we're going to be looking at Pythagorean theorem problems in the real world. So these aren't exactly notes. You will find them. Let me go back to third hour. Okay, so this is the Pythagorean theorem in the real world. So this is the document that I've opened. And we're going to go through a couple of these problems together so you can jot down the work and have examples of those. And then you're going to be finishing those for your assignment tonight. Okay, so here's the first one. Clayton is responsible for changing the broken light bulb in a street lamp. The street lamp is 12 feet high. Clayton places the base of his ladder 4 feet from the base of the street lamp. Clayton can extend his ladder from 10 to 14 feet. How long must the ladder be to reach the top of the street lamp? And will Clayton's ladder work? Round your answer to the nearest tenth. Okay, so I would sketch a picture. So here's street lamp. There's a little light bulb on it, and that is 12 feet high. Okay, then he is going to lean his ladder against it. There's his ladder. Well, this would be a right angle with the ground, and it says that his ladder is 4 feet from the base of the street lamp. So this would be 4 feet. So the question is his ladder tall enough to reach the light that he can change it? Okay, so Pythagorean theorem, but pay attention. Your hypotenuse is the x, so that's going to be your c. So your a squared plus b squared equals c squared. So this is 144 plus 16 equals c squared. Looks like it'd be 160 equals c squared. Okay, if we were simplifying this and doing in simplest radical form, when I take the square root of both sides, I would then do a factor tree and try to find my pairs. But you'll notice here it says round your answer to the nearest tenth. So I don't really need to do the factor tree because I'm going to round anyway. So in your calculator, do the square root of 160, and that's about 12.6. So C is going to equal 12.6 feet. Okay, so the question was, will Clayton's ladder work? And your answer is yes, it will, because it says it will extend between 10 and 14 feet. So yes, Clayton's ladder will work. Okay, let's do another one, the traveling problem. Leah walks to soccer practice on Saturday. She leaves her home and walks 6 blocks north. So she goes north. Oops, that's not a very straight line. Let's try again. Okay, so she goes north 6 blocks. Then she turns east and walks 4 more blocks. And then here is the soccer field. Okay, question is, how far is the soccer field from Leah's house? So if she could cut across everybody's yards, how far is it just to go from her house straight to the soccer field? Well, again, this is the hypotenuse. It's opposite your right angle, so that's going to be the side C, so the c squared. So it'd be 4 squared plus 6 squared equals x squared. So 16 plus 36 equals x squared. 52 is x squared, and then do the square root of both sides. And x is going to equal, again, it says round to the nearest tenth, so we're going to go square root of 52, and it's about 7.2 blocks. Okay, so Leah, it lives about 7.2 blocks from the soccer field. Okay, I want to skip down and look at a couple others just to kind of get them set up for you. Tom and Jerry want to put a custom-made round table in their dining room. The tabletop is made of glass with a diameter of 85 inches. The front door is 36 inches wide and 80 inches tall. Tom thinks the tabletop will fit through the door, but Jerry does not. Who's correct? Okay, so we have this door, and it is 36 inches by 80 inches. Okay, well, the only way this tabletop is going to fit through this door is if you can tip it, because if you stand it up on its side, it's 86 inches tall. It's not going to go through this door. So the question becomes, okay, well, if we do it at an angle, is that enough space? Okay, because we need 85 inches. So that's the question. Is that diagonal going to be 85 inches or more so that we can fit this top through the door? Okay, well, I've got 80 inches here, 36 inches there. Well, of course, this would also be 36 inches, and these are the legs, and then that's the hypotenuse. So we would go 80 squared plus 36 squared equals x squared or c squared, whatever variable you want to use. So you're going to go through that, solve it, and see if that is right or gives you enough distance that you can fit the table through there. Okay, I wanted to set up another one. Okay, this one. A television is identified by the diagonal measurement of the screen. A television has a 36-inch screen whose height is 22 inches. So this is 22 inches. Okay, on the diagonal. So this is true of your televisions, your laptops, your phones. So if your phone says, you're looking at getting a new phone and it says it's a 6.5 inch screen, then it's talking about the diagonal. So this distance right here. Okay, so there's the screen. We want to know what is the length. So this time we don't know this side, which is one of the legs. You do know the diagonal, so that's your hypotenuse. So this would be x squared plus 22 squared equals 36 squared, and you are solving this. Okay, now the reason I bring this up is I was looking at some of the homework that you were turning in on the Pythagorean theorem, and there's a couple people that weren't paying attention to the fact that you were given, in a couple of those problems, you were given the diagonal. So what you were solving for was a leg. Okay, so you want to make sure that you have the diagonal, the hypotenuse in the right place. So be careful. If you haven't turned that in, go back, look at that assignment again, and make sure if it was the hypotenuse was one of the pieces of information that you knew, that you put that in the c squared spot. Okay, that is all for today. That should give you hopefully enough direction that you can finish this and get that turned in.